So in question 6, we're given two different types of apples, one eating, one cooking. They can both be modeled as normal distributions. The eating apple has a mean of 100 grams, cooking has 140, standard deviation of 20 in the eating and standard deviation 40 in the cooking. We're also given that 95% of the weights are within 2 standard deviations of the mean. And we're asked to find the percentage of eating apples that weigh more than 140 grams. So 140 grams is mu plus 2 sigma. So I'll just draw a diagram, the normal distribution diagram, so it'll be a bit easier to follow. So the mean is at 100. Within 1 standard deviation, that's 120 on both sides. This, 2 standard deviations, 40 and 60. Now, 95% are within 2 standard deviations of the mean. So that means we're going to have 2.5% of the weight here and 2.5% of the weight here. And again, we're asked to find the percentage of eating apples that weigh more than 140 grams. So this, as I said, is simply 2.5%. So our answer is just 2.5%. So in question 6, we're given a lot more information. So we're given that we have new apples where 80% are eating apples, and both types of apples are picked and mixed. And from these apples that have been picked and mixed, the weights, the apples that have a weight of greater than 140 grams are separated into a container. And we have an apple that is randomly selected from the container, and we want to find the probability of that apple being an eating apple. So to start off, we're given that 80% are eating apples, so then we can just start with the tree diagram. So if I draw it here, I can say eating, I can have that eating, and C for cooking, I can write 80%. So tree diagrams, the branches always add up to 100% or just 1, so this therefore must be 20%. And from then, we know they're picked and mixed and are separated into or out of the container. So I can label this as I for into, and I'll label I dash as not into or out. And it's given that weights that we're given that apple types that have a weight of greater than 140 grams are separated into the container. Now from the question above, we were asked to find the percentage of eating apples that have a weight of greater than 140 grams, which is very similar to this. And we got that was 2.5%. So we know that 2.5% go into the container. So I can label that as 2.5%. And once again, this must add up to 1 or 100%. So this is going to be 97.5%. And for the cooking apples, our mean is 140 grams with a standard deviation of 40. But since our mean is 140 grams, if I quickly just draw in normal distribution, our mean is going to be here for the cooking apples. So it's going to be a 50% chance of it going into the container, and therefore it must also be a 50% chance of it going out of the container. And now recall that the question said the apple is randomly selected into the container. We want to find the probability of that being an eating apple. So reading it really closely, we want the probability of it being an eating apple given that it is into the container. So that screams conditional probability. So we want P of E given I. And from the conditional probability formula, we can say that that is equal to P of E and I all over P of I. Which P of E given I is simply 0.80% times 2.5%, which is 80% times 2.5% over P of I is going to be this plus this, because that's everything related to I. So it's going to be 80 times 2.5% once again. So 80% times 2.5% plus 20% times 50%. 20% times 50%. So 80% times 2.5%. 80 times 2.5 is 200. So that's 200%. 200% is simply 2. So we have 2 over, if this is 2, this is also 2. 2 plus 20% times 50%. 20 times 5 is 100. So 20 times 50 is 1,000. So that's 10. So it's 2 over 12, which is 1 over 6. And that's our final answer.